The pioneering research of the American University of Beirut has helped change several unsustainable practices in the Lebanese agriculture since the establishment of its experimental center in the Bekaa Valley. This presentation is a summary of another research by the university that contributes to the sustainable wastewater management and treatment in the university farm.
The goals of this research is to evaluate the efficiency of Azolla in purifying wastewater from impurities such as ammonium and phosphorus, and to evaluate the feasibility of growing Azolla in constructed wetlands to purify wastewater that is coming from university's farm in Bekaa region. This is the poster of our research, and we'll be going to talk about each part in the upcoming slides. We will start talking about the methodology. So the experiment was conducted at the university's Advancing Research and Enabling Communities, AREC. It is located at Hosh Sned in Bekaa Valley, around 1,000 meters above the sea. The first season of the experiment extended from April 6 to May 24, where temperature ranged between 19 to 30 degrees throughout the season. It was conducted under a greenhouse, and improvised pools were used as shown in Figure 1. The experiment was divided into 5 treatments and 3 replicates each. The treatments consisted of primary, secondary, and tertiary wastewater, along with positive and negative control. A complete randomized design was used to place all the replicates in the greenhouse. After data was collected, two-way ANOVA was used on SPSS to conduct significant difference between all the treatments, and the means were considered significant when p-value was less than 0.05.
The main problems that this research responds to are water scarcity, water pollution, and changing climatic patterns. These problems are exacerbated by global issues including alarming population growth, rapid urbanization, and industrialization. Therefore, shifting to non-conventional water resources is needed, and these include treated wastewater. Many of us think of wastewater as a problem itself, not considering it as a potential part of the solution. The reason we need to consider wastewater reuse is the fact that fresh water is a finite resource, whereas wastewater is characterized by year-round availability and the possibility of recovering energy, nutrients, and other useful byproducts. Moreover, recycling wastewater is a substantial part of the Sustainable Development Goals, specifically Goal number 6 and Target 6.3. An eco-friendly and sustainable technology for wastewater treatment is suggested in this research, and it relies on a process called phytoremediation. Phytoremediation originates from two words that together describe the ability of plants to remove pollutants from water. In this experiment, we use a free-floating aquatic plant called Azolla pinnata, shown in the picture below. The results of the experiment are very promising. For example, color and odor of all types of wastewater improved noticeably after growing Azolla pinnata on the water. Table 1 on the right represents the scale used for color and odor interpretation. For instance, the color of primary water improved from 0, which means extremely turbid and black, to 4, which means colorless and clear, by the end of the experiment.
The results of chemical properties of wastewater has shown that soluble reactive phosphorus has decreased around 96.4% in the primary wastewater treatment within 20 days. Also, the ammonium has decreased around 98.2% in the primary wastewater within 20 days of the experiment.
In conclusion, Azolla pinnata is promising for enhancing wastewater quality. The future scope is to grow Azolla in constructed wetlands at the American University of Beirut's farm in order to treat the wastewater generated by the farm sustainably and irrigate the endemic species threatened by water scarcity in the Bekaa region. Thank you for your kind attention.